Hello, Matrix, and welcome again. Today we are going to carry on with optimization. If you've watched some of the other videos, you do not need to be worried about optimization. You simply need to follow the steps that I've put down on the screen, and I'm going to show you how to do that. So without further ado, let us look at a question. And in the last question, the function in terms of one variable had already been done. So that step had been done. Now, this question looks like we are going to have to do all of our steps. Well, except possibly step 4. But here we go. Get function in terms of one variable. So what does that mean? So a function is just like our f of x equals x squared, or v of x, or one variable in terms of another, and we need it in terms of one variable. So let's just read the question and see if we can figure this out. A cool drink manufacturer wants to use at least the least amount of tin to make a closed cylindrical shaped can to hold 128 pi milliliters of cool drink. Okay, so we know it's an optimization question because they want us to find they put minimum in the question. So that's a key point there, right? So the first bit is, let's just draw a picture of a cool drink can. And so we've got one here, a very bad picture. And it says that the volume, because the least amount of tin used to hold 128 mils. Okay, so that's this. So basically this tin here has to contain 128 pi milliliters. Okay. The radius is r. So let's make the radius, let's draw that in pink as r. And the height is h. So this is a question here where we've got two variables, r and h. Okay, and it says the radius, okay, calculate the radius of the cylinder so that the amount of tin used for the surface area is a minimum. Okay, so they want the area being a minimum. So basically what they want is a function a in terms of something. Well, the radius, so in terms of r. So we need to get a function for the area. Okay, so this says get the function in terms of one variable. So at the moment, if we were to get our area, we would have the area of this, of the tin, which would be, let's think if you were to make a tin at home, right? You would need the bit of the tin that goes around. So this bit that goes around. Okay, so if you were to spread this tin out, you'd get this, and this length here is the circumference. So this length along here is pi times d, so which is pi times 2r. And then of course you need the area of the closed, it's closed. So basically we've done the area on the top, around the sides. So, and then on the top as well, we would need to do that area as well to make the tin. So that would then be the two bits on the bottom. And so those, the area of a circle is just pi r squared, okay? But now this area, the circumference is 2 pi r, and then the height is going to be h. So let me do that in purple. So we take a can, the tin that's around the sides is h times 2 pi r, and then we've got this. But of course, this would give us, pi would give us 2 pi r squared because of the two circles. So there's two of them. So it'll be 2 pi r squared, these two, plus the pi r squared times h. Sorry, the 2 pi r multiplied by h. Okay, so this would be the area, but they want the function in terms of one variable. And so we have to get rid of this h somehow. And so we need the h in terms of r, and that is why they told you this. So step one of this is the hardest part of the question. But normally what they'll say is show that the area can be given as, and then it'll be in terms of one variable. So they'll allow you to be able to find the derivative even though you can't get the first bit of the question. But if they don't do that, it's very important that you are able to do this, which is it's probably the trickiest part. Okay, so what are we saying? It needs to hold 128 pi. So that means that the volume of this, and I put that in green, the volume must equal 128 pi because that's what it must hold. So the two equations that we're going to use, we've used the area, is now the volume equation. So the volume is basically the bottom, this area, and it would go multiplied by the height because that would then give you the entire volume. So the volume is equal to 128. Now the formula for the volume is the area of the circle, which I did in green, which is the same as the orange one, which is pi r squared. And then you would have to multiply that by the height in order to get the volume. But now they've also told us that the volume is 128 pi, which means we can make the volume 128 pi, and we can then use this bit here to get h by itself, because then we can sub that into this h here. Okay, so let me do h in purple so that it's, sorry, and then do h in purple. So it's this h that we need to get. So we're going to do another one of these because this is probably the trickiest bit of these optimization questions. The pi's cancel, and I can divide it by both sides by r squared. R squared, there's r squareds cancel, and then I get h equals 128 over r squared. Now I know that h is 128 over r squared. I can put that in here. So I put area equals, and I might as well just keep going with the purple, 2 pi r squared plus 2 pi r. And then h, this h is 128 over r squared. And you see now I have the function in terms of one variable. So I've done the first step. Okay, I just need to, this r is at the top, cancels with one of these r's. And so I get area equals 2 pi r squared over 128 times 2 is, so it becomes 256 pi over r, which is, when I want to derive it, I'm going to make this, instead of over r, I'll make it r, no, I'll make it r to the minus 1, because r can go to the top and become minus 1. Okay, so now I've done number 1. It was a little bit tricky, but I've done number 1. Now I need to find the derivative. This is going to be a bit easier. So now I'm going to do I'm going to do the second step in green. And so I'm going to say a dash r equals 2 times 2 is 4 pi. And if I take 1 off the r, I get r. Because it's 2 minus 1. Then 256 pi r to the minus 1. Minus 1 times 256 is minus 256 pi r to the minus 2, which is r squared. And now, so that's the second step done. Now I'm going to do the third step, which is to make it equal to 0. So 0 equals 4 pi. So this is, we did green step. Let me just take it. This was step 2. Step 3 was in yellow. 4 pi r minus 256 pi. And I'm going to say, instead of r to the minus 2, take it to the bottom and make it r squared. Now all I do is take one of these across. It's going to be easiest to take the 256 pi over r squared across. I'm going to do that because then it becomes a positive equals 4 pi r. Now, to get rid of the r squared, because I need to solve for the radius of, to calculate the radius, so I need to solve for r by itself. So, easiest thing to do is times by r squared on both sides to get rid of the r. So if I times by r squared on that side, the 256 pi cancels, the r squared cancels. I'm timesing by r squared, and then this becomes 4 pi r cubed. Now I need r squared by itself. I'm going to divide by 4 pi, and then I get r cubed equals 256, the pi's cancelled, 256 divided by 4 is 64, and so I get r cubed equals 64, the cube root of 64 is 4, and so my final answer is r equals 4. So I've done step 3, and the maximum would be where the radius is 4. Now this could be also substituted into the original equation if they wanted the maximum, the minimum area, but of course they don't want the minimum area, they want the radius so that the amount of tin used is minimum. So that would just be 4. So I don't need to do step 4 for this question. Okay, but you know how you would do it. You would take that 4 and you would substitute it back into your original equation for area, which is what you got, which is what you did in step 1. So you would substitute it back. I'm going to just highlight that in red, what you would make it there. You would substitute the r of 4 back into here, this one here. And so you basically say area where r radius is 4 equals, and then you put 4 where you see an r. Okay. So that is a optimization question. The first bit is tricky, and so you might want to just watch the video again from 1 onwards, just so that you work out how to do the function in terms of one variable. But I am going to do another one of these videos with a similar type of things so that you get used to it, and then hopefully you can do them on your own. So very important that you find the subscribe button so you get notifications on when I do these videos, because I'm going to be doing plenty of these Matric Maths videos to help you guys out. If it helped you, you please like with your friends, support the channel, subscribe, all that good stuff, and I will see you soon for the next video. All the best with your studying.